Welcome back, Year 5. In today's math lesson, we're going to do our last session on adding and subtracting decimals. We have two intentions. The first is to add and subtract decimal numbers with up to 4 digits from whole numbers. For example, 5 take away 3.728. Our second learning intention is to perform exchanges when there are zeros in the columns. That's something we've done before, so it shouldn't be too tough. Okay, let's look at the Think Together portion from the textbook. I'll show it to you on the screen.
All right, so I've set up my book and I'm starting at the Think Together portion today, question 1. So you should be seeing that on the left-hand side of your screen. It says there, how much pasta is there in total? And it shows me 2 bags of pasta. One is 5 kilograms and the other one is 2.8 kilograms. Well, it's asked me how much is there in total, so I know right away I'm going to have to add these up. And it's actually shown me on the side how to do that. What I noticed they did is they put a placeholder in the tenths place for the 5 kilogram bag. The reason for that is that 5, like this, just 5 kilograms, is exactly the same as having 5.0 because it's 0 tenths. It has no value, so it's still just 5 ones. But when I show it like this, it's much easier to add another number that has something after that decimal point. So when I add 2.8 to it, it lines up nicely. Rather than just having 5 plus 2.8, it looks a little funny, and then also I might mess up and put the 5 over the 8 instead. So this is a good way to play it safe. So let me stick a line through that. I want you to pause the video here, work it out real quick, and then press play. All right, so 0 plus 8, 8. 5 plus 2, 7. I hope that took you 5 seconds like it took me. So the pasta is 5 point, whoops, nope, my book's gonna be messy today. It's 7.8 kilograms in total. And that's my final answer. All right, on to the next one. So that was question A. Let me put a little A there. Now on to B. What is the total mass of the cereal? And it shows me 4 cereal boxes. 3 of them are 2 kilogram boxes, and the other one is 0.65 kilograms. So again, it's asking me for a total, so I know I just have to add them all up. Right away, I see 2 plus 2 plus 2, and I just know right away that's going to be 6 kilograms. And then I'm adding 0.65 kilograms to that. Again, to make this easier to add, I'm going to put some placeholders. 6 kilograms, it's still 6 ones, it's the 6's in the ones place, so that's going to be the same thing as having 6.00, because nothing is in the tens place, nothing is in the hundredths place. But when I write it like this, it's going to make it easier to add to 0.65, which has something in the tenths and in the hundredths. So let me stack them. Plus 0.65. And you should be able to do this one mentally, because we're just adding zeros. 5, 6, decimal point 6. So the total is 6.65 kilograms. That's how much cereal there is in total. I'm just going to underline my answer right here. All right, on to C. Make sure I skip a line. There we go. Zach pours some milk from the bottle into a glass, and I see there that the bottle has 3 liters. It says the glass holds 0.35 liters of milk. How much milk is left in the bottle? It shows me a diagram there of how I can subtract it, but I want to use my handy dandy column method. I love me my column method. So I have the number 3. I hope you guys can't hear that car passing in the background. It's one of those, you know, the ones that blast the wear your mask, stay safe, stay 6 feet from the person in front of you. It's one of those cars doing that thing. So I hope you didn't hear it. All right, where was I? 3 liters, take away the glass, which is 0.35. So 3 liters is the exact same thing as 3.00 because there's nothing there. I'm just using it to hold the place open. And now I'm taking away 0.35. I'm subtracting. All right. Got to steal. This turns to a 10, but then I got to steal again. Turns to a 9. This turns to a 10. There we go. 10 take away 5 is 5. 9 take away 3 is 6. This 3 became a 2. 2 take away nothing, 2. I breezed through that one because we spent so much time looking at how to subtract across zeros. I really don't want to bore you guys to death. So how much milk is left in the bottle? 2.65 liters. The biggest takeaway from this page is that when you have a whole number, like 6 or 7 or 12, it's exactly the same thing as when you put zeros behind the decimal point. You can put as many zeros behind that decimal point as you want, and the number keeps its value, because the zeros are just saying that there is nothing there. So all these numbers above are the same as the numbers below them. When you show them like this, though, it might make it easier for adding or subtracting. Alrighty, on to the challenge. Now, today's challenge I have some mixed feelings about, but I'll explain that in a moment. Now, you're going to notice at the top of the challenge it says Jamila uses 2 different methods to work out 2 take away 0.296. Here's her first method. I wrote it out again myself. What she did is she changed the number she was working with. She realized that if she tried to do 2 take away this, she was going to end up with a ton of zeros like this. So 3 zeros and then taking away stuff on the bottom, and she would have to regroup. So to avoid doing that, she took 0.01 away from the 2 and turned it into 1.999. So I'm just going to make a little note here. To get this number, she subtracted 0.001. She did that because it's so easy to subtract things from 9. 9 take away 6 is 3, 9 take away 9 is 0, 9 take away 2 is 7, 1 take away 0 is 1. But she had to do a little bit of extra work because she changed that too. Since she took 0.01 away from it, 0.001 away from it, she had to add it back when she was done. So she gave herself an extra step right here. So when she got her answer down here of 1.703, she said to herself, wait, because I changed that 2 by taking this away, I need to add it back to my answer at the end, making my final answer 1.704, which is correct. Another way she did it was, instead of just changing the 2 by taking away 0.001, she changed both numbers. She took 0.001 away from 2, and she also took it away from the other number, making it 0.295. Now, this method works as well because what she's done is kept the distance between the numbers the same. Remember, when you're subtracting, it's like finding the difference. So essentially what she was doing was finding the difference between 0.296 and the number 2, or 2.000. When she changed them by moving it back a little bit, she moved it back 0.01. She moved 2 back by 0.01, but she also moved this back by 0.01. So the distance in between the numbers stayed exactly the same. So she's still jumping the same amount. So the difference, exactly the same. So she ended up getting the right answer, 1.704. I'm going to be very honest with you guys. I hate these methods. To me, they're a lot more work than just regrouping, because you have to think about how you're changing the numbers and why you're changing them, and then you have to remember at the end, oh, if I took it away here, I need to add it back here, but if I take it away from both of them, I don't need to add it back. To me, it's a lot of work. So my preference is just to regroup. I love me some regrouping. You guys know that. So let me show you my preferred method. All right. More on the floor. I got to go next door and get 10 more. Unfortunately, there's nothing next door to begin with. So I have to keep jumping next door until I find something. I can steal from that 2, turning it into a 1. I give what I stole to the next place over, but I'm still trying to get it here, so I got to steal again. That turns to a 9. This becomes a 10. Come on, refocus. There we go. Then I steal again. That becomes a 9, and this becomes a 10. There we go. So now I've regrouped it so that I can subtract easily. 10 take away 6 is 4. 9 take away 9 is 0. 9 take away 2 is 7. 1 take away nothing is 1. And I still got the exact same answer. Now, it's up to you. If you like this idea of adjusting or compensating, go right ahead. I know there are some students who definitely prefer it. They say, well, let me just knock 0.01 off of both of my numbers, and then I won't have to do any regrouping. Personally, I think this is easier because you won't get yourself mixed up. You're working with the numbers that you were given, and you don't have to remember to do anything else to them at the end. You've just got your answer.
Before we move on to the independent work, I would like all of you to try part B of the challenge. It says use your preferred method to work these calculations out. Notice that all of them are a whole number minus a number that has a whole and some parts. So it's up to you how you would like to do it. You can compensate like Jamila did and balance things out, or you can just do some regrouping. Remember though, that whole number, you need to put the decimal place and then put some zeros behind it to make it a little easier to work with. When you're done, you're going to move on to your independent work. All right, now it's time for your independent work. Today comes from pages 27, 28, and 29, but there's a few things I want to highlight from those pages. For question 1, I want you to do the A part, but do you see the part that I put a line through? You don't need to answer that question. I don't feel that it's very necessary. If you can solve the problem one way, I don't need you to explain to me another way to do it. For question 2, it says all these calculations have the same answer, and then you need to find the missing numbers. Well, to do this one, solve the first one first, because then when you find the answer, you can take that answer and then just put it in as the answer for all the rest of them. And then when you know what the answer is for the rest of them, you just need to figure out what the missing number in between is. So what do you need to add or what do you need to subtract to get to that answer? All of them will have the exact same answer. Now for number 4. It says Bella worked out 5 take away 2.84 by doing 4.99 take away 2.83. And then it asks you to use her method to solve these problems. All Bella has done is she's just taken 0.01 away from both of the numbers so that she won't have to regroup. That way 5 became 4.99 and 2.84 became 2.83. It won't affect her answer because she did the same thing to both numbers. You need to do the same to the number sentences you're given below that. If you are stumped, just solve them the regular way by regrouping. Personally, I prefer to just regroup because to me it's one less step than having to change the numbers. So it's your choice how you solve number 4. For number 7, I just wanted to point out that it's a two-step question. First, you have to find out the total amount of milk and the total amount of lemonade before you can find the difference. So you're going to have to add and then subtract. Finally, number 8, the challenge. Today it's actually quite simple. It's just balancing number sentences. All you have to do is find what the one side is worth that has all the information and then make the other side equal the exact same thing. When you're done, don't forget to send pictures of your work to me, and as always, stay safe and I'll see you soon.